Alrighty. Hello everybody and welcome to this week's version of our Developer Office Hours. This is a series that we're going to run every other Wednesday from 3 to 4 p.m. Pacific time, and it's sponsored by the fine folks over at Crittercism. Today, if you missed our talk last week, it was largely about wearables, in particular the Apple Watch. And today we're going to focus on the other side of the same coin and look at Android Wear. So I want to start off just kind of recapping a little bit about what we discussed last week, as well as a brief overview of the wearables market as it stands, particularly for watches, and then show a few of the differences between Apple Watch and Android Wear and why they're both important to the ecosystem. And then finally, we'll get into some code and see it in action. We've got a nice open source project that we're going to show off to get you up and running on an Android Wear app within 30 minutes or less guaranteed, or your money back. And finally, once we are done with the structured content, we'll open it up to our regular roundtable Q&A, where we're just happy to discuss pretty much anything under the sun. If we can keep it tech related, even better, but I'm open to just about anything, so we'll see how it goes. So a quick word about myself. I've been an iPhone and Android developer for as long as you can have been an iPhone or Android developer, probably about 7 years or so. I've been building apps, and I currently work with a company called Whitewater Labs. We're a small development shop, and I'm based out of South Carolina. But I've been using Crittercism in all of my apps since around 2012, and they've been really, really helpful in me figuring out what's going on with my app, and I'm a really big fan, so that's why I'm really happy to kind of chip in, and I'm glad that they're able to work with me in this kind of regard. So a quick word about Crittercism. They are a mobile app performance monitoring tool, and that is a big mouthful, but it's pretty simple when you boil it down. And they basically answer these kind of questions for you. What happens if your deployed app breaks on a user or crashes or runs slow? All these things that can degrade a user experience. You as a developer, you don't necessarily know that these things are happening, especially once you've deployed the app, it's out in millions and millions of hands all over the world. The last thing you want to do is end up with something like this. And when I was first getting started especially, I would get these things all the time. And they are very, very frustrating to see one-star reviews in the App Store with zero context about why these bad things are happening to the users. So to avoid it, that's what Crittercism, that's what their goal is to try to avoid those gnarly bugs and at least resolve them as quickly as possible when they do pop up. So they give you all kinds of diagnostic information about why the crash happened, the context around it, why is your app running slow, why is the user experience crappy, all these things that you need to know as a developer to keep those 5-star ratings. Crittercism is able to help you out. And they're able to do it with a single line of code. So for me as a developer, it's a total no-brainer. I just plug this into every project, and they give me a lot of insight into my apps, so I can keep those 1-star reviews out of the App Store. So that's my 2 cents about myself and about Crittercism. So now we'll get into the good stuff. And the good stuff today is going to be Android Wear. I showed this slide last week about kind of the progression of smartwatches over the past few years. We started with Pebble, and last week we really highlighted Apple Watch because the media has really been highlighting the Apple Watch, and with good reason. But we don't want to forget about these other guys, and that's why today we want to talk about Android Wear. So why Android? If you look at this chart, you'll never ever want to develop an Android Wear app ever. But let's take it in context. So Android Wear in their first year, they sold around 720,000 units. Apple Watch, these are projections shown in the graph, but Apple Watch outsold Android Wear in their first day of pre-sales. So Android Wear did 720,000 in the first year. Apple Watch did 900,000 in the first night of pre-sales. So you can just tell the effect that Apple has on kind of the market in general, where they can bring this watch, this device to that many people and kind of raise awareness about the entire space. So Apple Watch is projected to do Even at low estimates, somewhere between 16 to 20 million unit sales this year, where Android Wear is significantly below that. But if you look at history, particularly with the smartphone, of course, Android market share is significant. And it's not only significant, it's around 3 times what Apple's is. So this blue line here is Android market share in the smartphone market. And this guy down here is iOS. So about 20% for Apple and around 63 to 64% for Android. And this is really the number that makes the smartwatch race interesting because, of course, Apple started off with the iPhone and they were the leader in the space for a while. But then Android just crept up, and then is now annihilating iOS when it comes to number of devices shipped with their operating system on it. So we can look at this. It might not work out exactly this way in the watch category, but it could be an indicator of what could happen with this market. So it's something to keep in the back of your mind as you look at these initial sales numbers from Apple. Now, if you look at the total device sales that are shipping these operating systems, last year Android for the first time shipped over 1 billion devices running Android on it. This is phones, tablets, all that kind of stuff, where iOS was hovering in the 150 to 200 million range. So Android is just permeating every culture, every country in the world with a huge array of devices. And if I was a betting man, I would bet that Android is going to do roughly the same thing in terms of the watch market. Now, this is a chart we published in a Crittercism report pretty recently, but it shows the number of compatible devices with Android Wear. So we talk about these 1 billion devices that are being shipped with Android every year. Over 50% of those devices are now available with Android Wear support. So this year, 2015 that we're in right now, you can guarantee that Android is going to ship over 1 billion devices again. So over 500 million devices are going to be Android Wear compatible out of the box. And that's just a huge number to throw around and one to keep in the back of your mind again when you're deciding whether or not you should develop for Android Wear. How's it going, Alicia? Good? I'll cut this out of the recording, don't worry.
Okay, I'm learning a lot, so there's that.
So now when we look back at the watch sales for the first year, we need to remind ourselves of how history has kind of worked out between Android and iOS. So Apple Watch is really dominating the market as it stands right now, but they're probably just making the watch culturally relevant. And as Android Wear is able to come out with different device types at different price points, especially, you can guarantee that they're going to catch up in this market share. So how about all the tech behind the watch itself and the OS? As I mentioned, Android has always been good at getting their operating system out on a number of different devices. You look at the number of Android phones out there, and they're almost limitless. And as a developer, it's a double-edged sword because those devices are getting in everybody's hands, but you have to also support all of those different devices, which can lead to larger issues in and of itself. But Android is already operating on, I think, probably 8 to 10 different devices, and they're coming out with more all the time. And as the smartwatches get more popular, you know that other manufacturers are going to come out with their own versions of Android, their own types of watches themselves. So for those who want to get creative, for those who want to get something besides an Apple Watch, they're going to turn to Android and all these different devices that are coming out. And another thing worth noting from a development side is that the Android SDK, or Android Wear SDK rather, is a little bit more mature. So they announced it last year around this time, I think, back at Google I/O, and it was made publicly available last summer. So it's been in people's hands, it's been in developers' hands for around a year. And that means they've gotten some issues resolved, and the SDK has advanced itself a little bit farther than where Apple has been able to go just yet. And just as they do in the phone world, they're going to be going back and forth for years, but right now Android has a little bit more mature SDK. Now, to make a comparison on how these watch apps really operate, we'll start by looking at Apple Watch. And this is a graphic we showed last week, kind of describing the flow of data between the Apple Watch and the iPhone. So the iPhone, it's got all these nice things in it. It's got GPS and cell phone and Wi-Fi. And those are what really make apps useful at the end of the day, right? It's got all this processing power, and it's able to connect to cloud services. But the big limiting factor when you're developing a watch app is that the watch app is really an extension of your iPhone app. So the watch is almost 100% dependent on having an iPhone nearby where it can execute code and execute these higher value methods that you really need to make a valuable app. And this is a huge limitation, and Apple is already addressing it, saying, we know this isn't going to work because the runtime is slow, the battery is getting drained, and people are having a generally bad experience with the watch. So they're rapidly working to fix this. But Android Wear has already resolved this problem. So they've got the phone that's still the main driver, right? So you still need the phone for GPS and cell phone data, but you're not totally dependent on it. Wear devices can already talk independently to the cloud through Wi-Fi. They have that capability. And they also have a very nice data sync layer that we'll talk about here when we dive into the code that allows the Wear device to send data to the cell phone without being in Bluetooth range. So if you wear your watch to work and you forget your cell phone at home, these two devices can still talk to each other over Wi-Fi. And that's a really nice advantage for user experience, but it's also limiting the dependency between the Wear device and the phone. So you see things like improvements in battery power and just general user experience improvements because the Wear device is not throttled to the iPhone, or the phone rather, and the phone's performance. Now I want to get into the actual code, where the differences kind of pop a little bit more, and also so you can get your own project up and running. We've got a full open source demo available at this URL. I will show it at the end of the video, and if you're watching this on YouTube later, it'll be down in the video description. So give me just a moment here, and I'll set up the stuff needed for the demo. Code on the screen, everybody always loves that. Okay, now just one note before I start the demo. So I've got two screens here. I've got a phone screen and a watch screen. I've got the Android device, the phone device here plugged into my computer. So this is a physical device and I'm just screencasting it. Let me see if I can show it. Yes. So I've got my Android device here and it's plugged in to my USB. And if you're looking for a nice development phone for Android, I'm using a Blue phone, BLU. And I got it unlocked on Amazon for 50 or 60 bucks. It's running KitKat, so it has full support for Android Wear. And it's been really solid for having a nice development device actually in my hand, which I know all developers appreciate. So I'll be using this device in the demo. And then back to the screen, I have an Android Wear emulator that we went and set up through Android Studio. And if you need a little bit of help setting up the emulator, you can do that. We've got full links in a tutorial that I'll post at the end of the presentation that points to Google's Docs. And they've got some great ways to set up the emulator and not only get code running in the emulator, but also being able to connect your emulator on your computer to a device that I have holding in my hand. So you need to do some port forwarding and a couple command lines to ADB, but it's not a huge deal, and it takes just a few minutes to get these two devices talking to one another. So this is our setup. It's going to be a little bit different from everybody, or for everybody, and we're going to use Android Studio as our IDE. So the demo that we're going to be showing is based almost 100% on a Google demo, which is this location sampler. And essentially what this app does is grabs the latest GPS location and displays it on the screen. You can start the GPS or stop it, and it'll automatically update every 10 seconds. So you're probably not going to have a whole lot of success if you just bundle this up and throw it in the App Store. But it's a nice, quick demo that we can use to show off the communication between the phone and the watch, and also some, oh, my American Express is due. So we can at least show off the communication between the two devices, and also use hardware that's only available on the phone, in this case the GPS, where the Android Wear device has to rely on the phone for this information. Now if we look at the code, I'll start with the phone side of things in our main activity. If you're an Android developer, this is looking very familiar. We've got our onCreate method. And we're just unpacking the user interface and setting up our text views and our buttons. But at the end, we're setting up a Google Client API. And that's calling this method right down here. If you haven't used this before, it's pretty simple and hopefully self-explanatory, but it's connecting to different Google APIs. And this is an asynchronous method. So what we're doing is calling our Location Services API and our Wearable API. And the Location Services, that's going to connect to the GPS, and the Wearable is going to allow you to connect to the watch. And I mentioned this is an asynchronous method because these things take a second or two to initialize. And once they're ready, they're going to have a callback and say, okay, we're ready to connect to the wearable and we're ready to connect to the GPS. So once this is all set up, we create our location request. Say we want to update our location, in our case every 10 seconds, and get as good of accuracy as we can possibly get from the device. Now once our GPS is set up, every time the GPS updates, which in our case is going to be every 10 seconds, it's going to call this delegate method, or this callback method, on location changed. So this is just receiving a new location from our GPS and setting it to a class variable. We go in and we update our UI, which is essentially just setting the text views that we saw in our screen back over here. We're just setting the latest latitude, the latest longitude, and the update time every 10 seconds. So we're doing that right here in this method. And before we talk about this next chunk of code, I want to talk about how we set up the Android Wear app. If you're starting from scratch, or if you're starting from an existing app, you can add an Android Wear module by right-clicking on the app and opening the module settings. So you can see we already have a Wear module here, but if you were creating a new one, you can just create one through this plus button, and then Android Wear module, and follow the dialog until you complete it. And then you'll get this new module, Wear Location, installed right in your project. And this is where all the code is hosted. You'll notice it's very similar to a regular phone app. It's got a manifest file, main activity Java class, and also some layout files as well. And this is all solely for the watch app. So we'll take a quick look at what the layout looks like. I clicked on this rect activity main file. You'll notice there's also a round one as well. And that is the difference between this square user interface and the round one. Those are the two watch faces that Android currently supports. And if you're building a production app, you want to, of course, adjust for both of these. But for example's sake today, and to keep things short, we'll just stick to the square and use this interface. You can see we've got a latitude label, a longitude label, and an updated label. These are just text views that are displaying our latest coordinates that we're receiving from the phone. If you double click them, you can see we've got IDs for each label. And these are essentially the bindings that will tie back into our code. So this isn't rocket science. We just want to show the latest coordinates on our watch app. So our layout is very simple, and we're just going to leave it at that. If we go into the Java class, so our main activity for the watch, you're going to notice we've got another onCreate method. If you're familiar with Android development, this is all going to come very, very easily to you. So it's a very low barrier to entry to add a watch extension or watch app to your existing Android app. We're going to do the same thing as we did in the phone and inflate our view and tie all of our text views to some class variables, and then create the same type of API client that we created from the phone. And in this case, we're not adding the location API, but we are going to add the wearable API. And that's going to allow us to connect to that data layer that allows the watch device to connect to the phone. So the same thing applies. This is an asynchronous method, and once the wearable API is connected, we're all good to go. Now, if we want to build and run this thing, it's, again, the exact same as you would do it with a phone app. So we'll select our target here, wear location, and build and run it. Now, if I pull up our emulator, you can see already we've got our device and our app running, and it's showing the latest coordinates that were retrieved from our phone. So every time this location updated toast shows up, you'll notice that our time syncs up, our latitude and our longitude both sync up. So we've covered the user interface on creating these labels. How is the data being thrown at those labels? How is all that being connected together? And for that, we'll go back to our phone. So our main activity in our phone, this is the method we just went over, where every time the location changes from the GPS, we run this method. And we create this data map. So all this is, think of it as a dictionary or hash map, but it's got a specific ID associated with it. And in our case, we named it location. This is an arbitrary string that needs to have value for only your application. So it knows which requests that it's supposed to be making, and both sides know where to find the appropriate data. So in our case, we name it location. We grab our data map and we store all of these attributes to the data map, so latitude, longitude, and the last updated time from our phone. We then make a request and store this request as a data item in our data API. And this wearable.data API, that's the layer that we showed earlier in the slides. I'll actually pull it up here for a quick reference. It's this data sync layer right here. So when we say put a data item to our data API, it's just throwing it at this sync layer. And this sync layer will be automatically propagated over to the app the next time it's open, and vice versa. So going back to our code, that's all that we have to do from the phone side to throw this data at our watch. And of course, we need to handle when this data changes from the watch side. And if you followed our iOS and Apple Watch tutorial last week, you know that we had to pull the iPhone every time the watch wanted to get updated data. So we had a timer running every 5 or 10 seconds, pinging the phone and saying, hey, is there new data? Is there new data? And as a developer, that just makes me cringe because it's ugly and it's also a battery drain. We don't like to just be pinging different sources all the time. And one of the great things that I enjoyed about working with the Android SDK is that they have automatic listeners for every time the data changes. So anytime the phone stores new data onto that sync layer, we get this callback method on the watch side that says, okay, the data has changed, go ahead and do something with it. So that's exactly what we're doing here in this callback method in the code on the watch side. We pull out the data item. This is the dictionary or the data map that we set in the phone. And we compare it to our unique identifier. So we want to grab only the location data. You might imagine a use case where you're sending different types of data back and forth. Think of them as tiny little databases sitting in the sync layer. You only want to access the proper database. So first we want to make sure that we're only getting the location data so we know exactly what to do with it. We expand the data map and set all of our watch labels, our watch text views, to the latest values in that data map. So it's extremely simple to extract the data out of this sync layer, and even more simple to notice when the data is changed. You probably noticed that we're running a handler, so we want to execute our UI code on the main thread. So we've got this runnable setup and our main thread handler set up as well. This is something you're probably very familiar with if you're an Android developer. Sometimes this onDataChanged might be thrown in a background thread. So we want to make sure we're running on the main thread so the UI updates properly and at the right time. So that's all we're doing here with the handler and the runnable, but the real code is happening right here, where we're just setting our text views to the latest data. And that's really all you need to be able to link the latitude and longitude on the phone directly to the watch device. Just a few lines of code. It's really, really nice and easy to use. And it was really a pleasure working with Android Wear. We were able to get this up and running in no time flat, it seemed. And it opens up a lot of different possibilities of being able to sync the two devices, sync data between the two devices. So to recap everything from the content today, Android there's still a huge follower when you look at the sales numbers. But don't let this discourage you, because this market is going to change drastically. And Apple Watch has brought watches to the forefront. More than just techies are using them and kind of playing with them over in Silicon Valley, but this is something, the Apple Watch is really making it relevant for everyday users and bringing it to the mass market in a way that Android just could never do. But what you can guarantee is that once people start getting awareness and the watches become a little more accepted, the hardware is going to catch up, and both in terms of functionality and price point. And once the price point starts to drop, I think we'll see a lot more people adopting the watches, both Apple and Android. But Android has a knack for creating the latest and greatest technology because they are able to work with so many different device manufacturers. So people are going to be able to customize the hardware just as they're able to customize the software now. And that's going to open up a whole new world for new buyers of these smartwatches. Beyond the hardware, the software is going to evolve as well. So if you look at the original iPhones and smartphones that were thrown out there, all they were doing was really just shrinking down what we knew on the desktop. So full websites or desktop applications, they were shrinking these down and just kind of smashing them into the phone. And that's kind of what's happening with the watch right now. We're taking things that are on the phone and just kind of jamming them into the watch because it's the latest thing to do. But just as the phone has evolved, the watch is going to evolve as well. User interactions are going to change. The way that people use watch apps is going to change drastically over the next few years as developers like yourself get more ideas and start to experiment more with the way that users interact with these new devices. So just as the hardware is going to evolve, the software will as well, and that's what's going to make these devices kind of sink or swim, is whether or not developers are able to create software that's compelling enough for people to adopt these watches in everyday life. And as we were able to show today through the code, it was maybe 50 lines of total code, and you're able to get a watch app running that is a nice parallel to your existing Android phone app. So this low barrier to entry, if you know Android development now, you know Android Wear development. And that's going to make it very, very easy for developers to support more than one OS and more than one device. So why not jump into this market early so you're one of the first ones in? There's still only a few thousand watch-compatible apps out there. So we're going to see more and more of these apps pop up as time goes on. And it would be great if you and your company were able to get in while the getting was good, as it were. So the low barrier to entry is really going to make it easy for developers to get new content out there. And that's going to do it for our structured content today. Once again, we've got our open source demo, the one that I just walked through, available on GitHub. And within the README of that file, or of that project, we've got a link to the full written tutorial that will walk through every step and every line of code. So it'll go into much greater detail if you want to learn the ins and outs of how the app worked. It's a great tutorial, and it's linked through that GitHub page and also through the YouTube description below. Also, follow the good folks over at Crittercism. They've got a lot of content out on their blog, keeping trends keeping track of the latest iPhone, Apple Watch, Android Wear, all of the good stuff that you're itching to know. They're tracking it weekly on their blog. And also their social networks. You can find them pretty easily on Twitter, LinkedIn, Facebook, whichever one suits you the best. One thing that I want to add is if you're looking for dedicated Crittercism support or just want to go ask the Crittercism team some questions, they run a great weekly webinar. It'll actually be tomorrow morning, so every Thursday around 10 a.m. Pacific time. The support team over at Crittercism talks about some of the new features that they're coming out with and runs some demos, and is also there really to just answer any questions that you might have about integrating with the Crittercism product. So go check that out as well if you've got some questions about Crittercism. And hopefully we will see you here in 2 weeks' time where we come out with our next version of Office Hours. So thank you so much for listening, and hopefully we'll see you in 2 weeks.